Alright, today we're going to look at solving quadratics using the quadratic formula. This is the same 6-problem worksheet that we'll be doing in class on Tuesday, October 25th. Let's get started. Okay, so if we have a quadratic, we can solve it by using the quadratic formula. First, we need to make sure it's in standard form, meaning we have our x squared term, our x term, our constant term, all equal to 0. We start by identifying the three coefficients. So a, the coefficient of x squared, is 1, b is 5, and c, the constant, is -6. Our formula, the quadratic formula, is this. And so now we go ahead and just substitute a, b, and c and simplify, and we'll have our solutions. So x equals negative, and then we insert our b value, which is 5, plus or minus the square root of 5 squared minus 4 times the a value times the c value. A value is 1, c value is -6, and that is all over 2 times my a value of 1. Let's continue to simplify. So I have -5 plus or minus the square root of 25. -4 times 1 is -4, times -6 is positive. 4 times 6 is 24. Let's double check. Yep. All over 2. Go ahead and bring this on up here. Keep simplifying. X equals -5 plus or minus the square root of 49 all over 2. X equals -5 plus or minus 7 all over 2. And so we have two solutions here. We have x equal to -5 plus 7 divided by 2, and x equals -5 minus 7 over 2. So x equals 2 divided by 2 is 1, and x equals -12 divided by 2 is -6. So my solution is x equals 1 and -6. Now something I want us to notice is the value of the discriminant. So the discriminant is the radicand, meaning it's b squared minus 4ac. It's the value underneath the radical. Once again, the radicand is what's underneath the square root. So what is the value of b squared minus 4ac? Remember, the value of the radicand was 49. The value of the discriminant is 49. We'll see at the end of this that the value of the discriminant is important in determining the number of solutions and type of solutions that we have. Let's look at the next one. This is in standard form. My a value is -1, my b value is 1, my c value is 5. My formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to substitute my values and simplify. X is equal to -1 plus or minus the square root of 1 squared minus 4ac. All of that is over 2 times a. And let's go ahead and simplify. -1 plus or minus square root of 1. Now this is -4 times -1 is +4, times 5 is +20. So I've got x equals -1 plus or minus the square root of 21 over -2. And that's as far as we can go. I can't simplify this radical because 21 does not have any perfect square factors. So we go ahead and stop there. Our two solutions are -1 plus the square root of 21 over -2 and -1 minus the square root of 21 over -2. But we go ahead and typically just leave it like that. You may see it split up. You may see it as x is -1 plus the square root of 21 over 2, and x equals -1 minus the square root of 21 over -2. You may see that. So this is our solution, and the discriminant in this case is 21. Let's keep going. It's in standard form. A is 3, B is negative 12, C is 12. Let's write down the formula. This you will memorize if you haven't done so already. Okay, negative 4 times 3 is negative 12. Negative 12 times positive 12 is negative 144. That's all over 2 times a, which is 6. Okay, so I've got two solutions, 12 plus 0 over 6 and 12 minus 0 over 6. But 12 plus 0, 12 minus 0, that's exactly the same, it's still 12. So actually I have one solution. I have one solution, x equals 12. Sorry, x equals 2. 12 divided by 6 is 2. In this case, the discriminant was 0. The value underneath the radical was 0. 0. Okay, so maybe you're starting to see a pattern with what happens to the number of solutions when we have different values of the discriminant. Let's keep going. Okay, this is reminding us that we need to put this in standard form. This is not in standard form yet because it needs to be equal to 0. So I need to subtract 5 from both sides to get 2x squared plus 4x plus 2 equals 0. Now we're ready to use the quadratic formula. My a value is 2, my b value is 4, my c value is 2. So let's go ahead and write the quadratic formula. And then substitute a, b, and c and simplify. And as we saw before, negative 4 plus or minus 0 is just negative 4. So I have one solution, negative 4 divided by 4 is negative 1. So my solution is negative 1. And the discriminant again here, the value underneath the radical was 0. 2 more. It's in standard form. We have it equal to 0. So I can list my a value, my b value, and my c value. I can write the quadratic formula. Simplify, but first substitute. Okay, negative 4 times 4 is negative 16, times 3 is negative 48. Okay, the square root of negative 44, we know that the square root of a negative is an imaginary number. So this is going to be 44 is divisible by 4. And this, so I'll go ahead and show the work. So this would be I times the square root of 44 over 8. I'll go ahead and show all the steps. Now 44 can be written as the square root of 4 times the square root of 11, because 4 times 11 is 44. Now the square root of 4 is 2, so this is plus or minus 2I root 11 over 8. And I can simplify this because there's a common factor of 2 in the numerator and denominator. I can think about factoring out a 2 from the numerator and factoring out a 2 from the denominator. Right, 8 is 2 times 4. These 2's cancel. 2 divided by 2 is just 1. So x is equal to 2 plus or minus I root 11 over 4. So you may see an answer written like this, or they may split it up into 2, saying x is equal to 2 plus I root 11 over 4, and x is equal to 2 minus I root 11 over 4. Let me fix that. So either one. You may see it written as how I circled it, or you might see it as written as 2 separate. Know that that's the same. Now what was the discriminant in this case? Notice that we have imaginary solutions. What was our discriminant? Our discriminant was negative 44. That was the value underneath the radical. Last one. Okay, I want to solve this quadratic. First I need to put it into standard form, meaning I got to bring this negative 4 over to the left. Good. Now I need to label my A, B, and C values. A is 5, B is 0, because notice there's no x term, so it's 0x plus 1. My C value, my constant, is 1. So let's go ahead and solve. And we'll use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Zero plus or minus the square root of 0 minus 20 all over 10. So this is plus or minus square root of negative 20 over 10. Okay, the square root of negative 20 is an imaginary number. 20 can also be simplified. The square root of 20, 20 has a perfect square factor of 4. So this is going to be plus or minus 2I root 5 over 10. Let's think about why that is. If I factor out a 4, the square root of 4 is 2. If I factor out a negative 1, the square root of negative 1 is I. And what was left? 5, because 4 times 5 is 20. Finally, I can simplify. There's a common factor of 2. So this is plus or minus I root 5 over 5. So this is my solution. What was the discriminant? The value underneath the radical was negative 20. So what I want us to notice here is that if your discriminant is negative, you're going to have 2 imaginary solutions. Notice we had plus or minus 2 imaginary solutions. On this one, 2 imaginary solutions. If the discriminant is negative, you'll have 2 imaginary solutions. If the discriminant is 0, you will have 1 real solution. You will have 1 real solution when the discriminant is 0. Just like we saw in the third problem, when the discriminant was 0, we had 1 real solution. And if the discriminant is positive, like 21 or 49, you're going to have 2 real solutions. Remember, this is not an imaginary solution. This is a real solution. It's just irrational, meaning the square root of 21 is not a perfect square. So that decimal is going to keep going on forever, but it's a real solution. We have two real solutions. If we were to graph this, we would see that it would cross the x-axis twice. Same thing here, the discriminant was 49. We have two real solutions. The reason why these are nice rational numbers is because 49 is a perfect square. All right, that is using the quadratic formula.